So hopefully you went to Google Classroom and you found this document called 2.2 Even and Odd Functions. And this is a really nice graphic organizer and a way for us to get our thoughts down, to separate what odd and even are. And then, of course, if it's neither even or odd, we just call it neither. And there's some graphs to look at, and then there's some algebra for us to plug in. So it really helps us figure some things out. I'm going to start here. A function is an even function if blank for all x in the domain of f. So what that means is if I take f and I plug in a negative x, I'm going to get the original back. It's going to look like that. Okay? The right side equation of an even function does not change if x is replaced with negative x, which means that when I plug negative x in, I'm going to get my original back. And it says even functions are symmetric with respect to the y-axis. That means that we can fold the graph on the y-axis and it would line up perfectly on both sides. Now what we're going to do is we're going to move over to the odd side. And in this case, a function is odd if blank for all x in the domain of f. And basically what that means is if I put negative x in to my function, what's going to happen is, and this is a strange notation, but try and follow it, my whole value of my original f of x is going to negate. So all of my sign values are going to be opposites. So when I plug negative x in, I'm going to get my whole function is going to end up being negative when I come out. That means all positives become negative and all negatives become positive. And it says every term on the right side of the equation changes if x is replaced with negative x. So all the signed opposites. And you can actually write that here. Odd functions are symmetric with respect to the origin. And that means we flip this thing 180 degrees and the image will be exactly the same. Now, it can't be exactly the same, but shifted. It's got to be exactly the same, which is really going to be clear when we actually look at the graphs right now. All right, so we're going to move down and take a look at these 6 graphs and see if they're odd, even, or neither based on the diagram. Now, if it's even, remember we're looking for reflection in the y-axis, so this certainly doesn't have that, so it's not even. Odd, we have to flip it 180 degrees, so I'm rotating it 180. Does it look exactly the same in the same position? No, it does not. And in fact, if you're off of the origin, it's not going to. So it's not even, it's not odd. This is a neither. For number 2, we've got symmetry with respect to y, which makes this even. This one, if I see, here's the thing. This has symmetry. Oops. This has symmetry with respect to y, which makes this even. See how it's the same on both sides. This one does not have symmetry with respect to y because the things on this side of the y-axis aren't on this side. However, if you notice the way this cubic is set up, if you rotate this 180 degrees, it's literally the same exact picture. Literally the same exact. So this is an example of an odd function. For number 5, it's not even because on this side of the y does not have the same thing as this side of the y. But if I flip this 180 degrees, it's literally the same picture. So this is an odd function. And our last one, this does not have symmetry with respect to y because this looks like it's going infinitely to the right, whereas it's not to the left. And when I rotate this 180 degrees, it's under instead of above. So that's not it. So this is considered a neither. So hopefully this helps you to figure out graphically whether you're dealing with an odd, an even, or a neither. All right, second page, we want to verify algebraically if it's even, odd, or neither. And basically, we have to do a little algebra proof. So this kind of gives you the directions of what to do and an example of, is it going to be this, is it going to be that, or whatever. Things to keep in mind. If it's even, that means you have to prove that when you plug negative x in, you get a regular function back. So you would get the same thing that you started with originally. If it's odd, you're going to put the negative x in, and what should happen is your entire function should change sign values. And if it doesn't come out to be exactly the same as the original, or all of the signed opposites of the original, then it's called neither. So this is kind of like what you do. You take your f of x function, and you're going to plug a negative x in everywhere you see an x. So in this case, we're going to do negative x squared plus 3 times negative x plus 5. And then we're going to actually calculate this. So negative x squared, negative times negative, that's going to give us a positive. This is 3 times negative x, which is negative 3x, and plus 5. Okay, so here's the thing. Here's if it's even. Do we get the same exact thing we started with? Do we have an x squared? Yes. Do we have a positive 3x? No. So this is not even. So now we're going to compare it to see if it's odd. If it's odd, all the signs would be different. Okay? Then that means that we should have all sign changes. So let's take a look. This is what we have in the beginning. So if we change all the signs, this should end up being a negative x squared, a negative 3x, and a negative 5. Is that what we got when we plugged it in? Did we get a negative x squared, a negative 3x, and a negative 5? No. So it's not odd, which means this is an example of neither. Okay, so either it has to come out exactly the same, or all of the signs have to change. Okay, and if all the signs change, then it's an odd. If all the signs are back to normal, like what you started with, then it's an even. What we're going to do is take a look at some examples. Okay, so basically all we have to do is substitute in negative x everywhere we're seeing x. So negative x to the third minus 6 times negative x. What we're looking for, if it's even, we should get the same thing. If it's odd, we should get the signed opposites of this. If we don't get one of these, then it's neither. So plug in, let's see what we get. So negative x times negative x times negative x gives us negative x to the third. And negative 6 times negative x is positive 6x. Does this match one of these? Absolutely. It matches this one. So this function is odd. Next one. If it's even, it should turn out to be exactly the same. If it's odd, it should be the signed opposite of what you're given. If it's neither, it means it's none of those. Let's substitute in. So this is negative x to the fourth minus 2 times negative x squared. When I do negative x to the fourth, a negative times a negative times a negative times a negative is a positive. So it's going to be a positive x to the fourth. And a negative x squared is a negative x times negative x. That's a positive x squared. And negative 2 times positive x squared is negative 2x squared. Does this match one of these? It sure does. This is an even function. Okay, for number 3, if it's even, it's going to come out exactly the same, x squared plus 2x plus 1. If it's odd, it's going to be the signed opposite, negative x squared minus 2x minus 1. So what we're going to do is we're going to substitute our negative x in. Negative x squared is going to give us positive x squared because a negative times a negative is positive. But this is going to give me a negative 2x. Does this match even? No. Does it match odd? No. Then that means it's a neither. 2 more. If it's even, it's going to come out to be exactly the original. If it's odd, it's going to be the signed opposite of the original. Let's substitute negative x in. Negative x squared is positive x squared. Even. Last one. If it's even, it's going to be exactly the same. If it's odd, it's going to be the signed opposite. Let's plug in. All right, now watch your signs here. This is a negative x to the third, which is going to give you a negative x to the third with a 7. So negative 7x to the third. This is a minus minus, which becomes a plus. Does this match one of these? It sure does. So hopefully this gives you a very good idea as to how to determine whether a function is odd, even, or neither based on algebra and based on graphs.